Number 14 says a rock is dropped from the edge of the cliff. Its distance is s in feet from the top of the cliff. After t seconds is given by this equation. We're going to assume the distance from the top of the cliff is 1,600 feet. We're going to complete parts A to B. It says, when will the rock strike the water? Okay, so we know the rock will strike the water once it gets to 1,600 feet. So we can just set up the equation to find out when S of t, the position, which is equal to 16t squared, is equal to 1,600. So when it gets 1,600 feet below, it's going to hit the water. So we can divide by 16 and factor that, and that gives us t squared equals 100. 16, just give us 1 basically. And then if we do square root, we get t equal plus or minus 10. Okay, so after about 10 seconds, this rock will strike the water. Now we want to look at the time when the rock strikes the water. We're going to make a table of the approximate velocities. Okay, so we're going to do a difference of 1, and then 0.5, and then 0.01, 0.001, and then 0.0001. And this is average velocities and approximated at when it strikes the water. So we're going from, or getting closer to the 10 seconds. So again, I'm going to let the calculator do all the lifting for me again. We're going to go stat, enter. I'm going to pull up the tables. I'm going to clear each table out. Go to the top, clear, arrow down. Okay, so since we're getting closer to 10, we have 1, 2, 3, 4, 5 blanks. Okay, so we're going to do 10 5 times. We're going to go over, and then we're going to be at 9, at 9.5, and so forth and so on, because we're getting closer to that 10. So we're going to be at 9 on the first one, 9.5, 9.01. Oh, this 9.1 this time. .01. I think I got this backwards. I should be getting closer. So A is my 10. I should be going from 9 to 10 and 9.5 to 10. So I have these a little bit backwards. Looks like I'm getting closer to 9. And this should be 9.5 and 0.99 and 0.999. So let me fix these. It should be, we're subtracting it. So it should be 9.9. And it should be 9.99 when I subtract the 0.1 from 10. And when I subtract 0.001 from 10, I should be at 9.999. Okay. That looks better. We're getting closer to 10, not closer to 9. All right. Once we have that, we're going to do our y. So again, we're going to just use this formula with L2 minus L1. So we're going to say, open parentheses, 16, and then we're going to do t squared, which is the first one's going to be L2. Then do second L2 second, L2. All right, there we go. And then, so we got 16t squared Alright, we're going to subtract 16 times the t squared with the L1. Alright, this will give us our y coordinates. And then in L4, we're going to divide it by the difference. So we're going to say this is going to be equal to L3 divided by L2 minus L1. And then this starts giving me my velocities. So looks like the first value is 304. Put 301, 304, and then 312. And we want to round to 3 decimal places when appropriate. So then we have 318.4, and then we have 319.84, and then we have 319.98. And it says approximate velocity when it strikes the water. So as we round, the nearest integer looks like approximately 320 when we round to the nearest whole number.